Hello guys, we can discuss the amine chapter, the most important 100 MCQs. So I think when we discussing the 100 MCQs, I think after completing the 100 MCQ, we may cover the complete chapter concepts with the detailed solution. Okay, let us go for the first question. Okay, ready? Which of the following is the most preferred reagent for reducing nitroethane to ethylamine? Basically, nitro to amine. Which all are the best reagent to convert nitro to which one? NH2 amines. We studied it as per basic theory of the chapter. We use the reducing agents like hydrogen with the palladium in ethanol medium, or we can use iron and HCl, or we can use tin and HCl. These are the reagent we studied. Where we may study that this is the best reagent. Iron and HCl is the best. Which of the following is the most preferred reagent? That is Fe and HCl. There is a reason you may study that. So normally when we react with the iron and HCl, the iron and HCl first react, it will give you FeCl2. This FeCl2 again react with the water in the medium, give HCl back. So it's giving HCl back. So in the beginning we have to use less amount of HCl. So therefore the best reagent to convert nitro group into NH2 if they ask, we can go with which one? Iron and HCl. Okay. Next question. Which compound is formed when hydrogen gas is passed through nitrobenzene? Okay, nitrobenzene is here. Okay, nitrobenzene. They are passing hydrogen gas in the presence of finely divided nickel. Okay, hydrogen with a nickel or palladium catalyst. What happened? Nitro group converted to what? NH2. NH2, same reaction. Here we said the hydrogen with the palladium, or that what? Hydrogen with the nickel, same purpose. NO2 converted to NH2. What is that compound called? Aniline. Right. So nitrobenzene on reduction with the hydrogen, we get which one? Aniline. Next one. Nitrogen atom of amino group is dash hybridized. You know, amines are the derivatives of ammonia. Amines are derived from ammonia. What is ammonia structure? You know, NH3 we can write like this one. We know hybridization is given by, we may study it in 11th grade chapter chemical bonding. Hybridization is given by the sum of sigma bond and lone pair. How many sigma bond? 1, 2, 3. 3 sigma bond and 1 lone pair. So what is the total sum? 4. 4 mean 4 orbital we have to mix. So sp3, 1 s orbital and 3 p orbital. So remember all, ammonia is sp3 hybridized. Amines are derived from ammonia. So amines, primary, secondary, tertiary, these amines are what? sp3 hybridized in nature. Okay, pyramidal shape, trigonal pyramidal shape. So what is the hybridization of nitrogen in amino group? Mean we can say sp3 is the hybridization. Question number next, fourth one. C3H8N cannot represent. That's actually, let me write the formula CH3, CH2, CH2, NH2. Just to check the formula, all of you, 3 carbon, okay. 3 plus 2, 5, 5 plus, this is not a small thing here. C3H9N, okay, C3H9N. So this is the compound 1 possible. So C3H9N cannot represent, okay. So this is 3 carbon contain 1 amine. What is this amine? It's a primary amine because it contains NH2. I can write a secondary amine also, NHN, CH2, CH3. N-methyl ethanamine. This is secondary, right? It's possible. Even tertiary also possible. Even tertiary also possible, right? Dear all, hope you know how to understand its primary and all. If it contain NH2 group, primary. If it contain NH group, secondary. If it contain LL tertiary, right? So C3H9N, the formula can represent both primary, secondary, tertiary amine. Quaternary ammonium salt is not possible with the formula. Okay, so that is C3H9N. These are the structures possible. One more is there, actually the NH2 can be placed it here. Anyway, quaternary is not possible with 3 carbon. Next one. The most convenient method to prepare primary amine containing 1 carbon atom less. This is the only one chapter, main chapter we are studying how to get a amine with a 1 carbon less. That is Hofmann-bromamide degradation reaction. Hofmann-bromamide reaction. Through Hofmann reaction, you may study the amide from which 1 carbon less amine we will get it. So if you want to reduce 1 carbon in product, the amine, then the reaction will be what? Hofmann-bromamide degradation. Next, when excess of ethyl iodide, what is ethyl iodide? C2H5I. When excess of ethyl iodide is treated with ammonia, what is this reaction, my dear? Remember all, this is our ammonolysis. Ammonia, when treated with a haloalkane, we get primary amine. But you know, ammonolysis, what is the main demerit? It won't stop with the primary, it gives you secondary, tertiary, up to quaternary, the reaction continue. But there is some exception cases, you remember all. If you use ammonia in excess, if you use ammonia in excess and carry out with the haloalkane, primary amine will be the major product. Primary amine will be the major product. But if it is opposite, that means if you use the alkyl halide in excess, then the quaternary, the reaction will continue primary, secondary, tertiary up to the quaternary salt. Up to the quaternary salt, the reaction will continue. What is ammonolysis? Ammonia, when react with the haloalkane, we get amine. But it won't stop, that's a problem. It will continue up to the quaternary. But there is some points, experimental evidence is given that if you are using excess ammonia in the beginning, primary amine will be the major product. If you are using excess haloalkane in the beginning, it is always end up to quaternary. So here the question, if they are using excess ethyl iodide, if the reaction continue up to quaternary. So that means you will get tetraethyl ammonium iodide. Tetra, what is the tetra means? Quaternary ethyl ammonium iodide. Up to the quaternary reaction get continue. You know, ethylamine is primary, diethylamine is secondary, triethylamine is tertiary, but quaternary up to that reaction continue. Next question. Benzoic acid. What is benzoic acid? Benzene with COOH. Benzoic acid when treated with the SOCl2, thionyl chloride. What is the function of thionyl chloride? To remove OH and place chlorine, right? So what we get? Benzene with the COCl, benzoyl chloride. What is this called? What is this called? Benzoyl chloride. Benzoyl chloride. Okay, fine. Next. A product SOCl2 and the product X formed is. So this is the product X formed is. React with the ammonia. React with ammonia to give Y. What happen if you treated with acid chloride with ammonia? Cl and one H cut. HCl out, you get an amide. What is amide? Benzene with CONH2. What we call this amide? Benzamide. What is this amide? Benzamide. This is the compound Y. Okay, next. Y on reaction with the bromine and KOH. What is bromine and a base means? You know, NaOH or KOH, whatever. So, you know, this is an amide. Amide on reaction with the bromine and NaOH. This is our Hofmann-bromamide reaction. The CO group replace and or remove, you will get the product finally what? This is the compound Z. What is this? Aniline is the main product. So remember, benzoic acid when treated with the thionyl chloride, we get benzoyl chloride. Benzoyl chloride on reaction with ammonia, we get benzamide. Benzamide on Hofmann reaction, you get aniline. So Z, the reaction is what? Aniline. Question number 8. Amines that cannot be prepared by Gabriel-Thalamide synthesis. You may study the theory that through Gabriel-Thalamide synthesis, we can prepare which one? Primary aliphatic amine. Through Gabriel, we can prepare primary aliphatic amine. Aromatic amine is not possible. So, amine that cannot be prepared by Gabriel. Aniline. Aniline is which amine, my dear? Aniline is a primary aromatic amine. What is benzyl amine? Benzyl amine means benzene with the CH2NH2. It's an aliphatic, right? NH2 connected to alkane chain. What is methyl amine? CH3NH2, aliphatic, primary. What is isobutyl? Isobutyl means CH3CH, CH3CH2. This is called isobutyl amine. It's also primary. Aliphatic amine we can prepare through Gabriel. Aromatic amine cannot. So aniline cannot prepare through Gabriel. 9. tertiary amine have lowest boiling point among the isomeric amine. We studied what is the order of boiling point of amine. Primary greater than, secondary greater than tertiary. Because primary amine contain NH2 group, more hydrogen, so more hydrogen bond can create. And then only secondary, and least one is which one? Tertiary. So primary amines are more basic, then secondary, then tertiary, because primary amine contain more hydrogen bond, can form more stronger intermolecular hydrogen bond. So why tertiary amine very least boiling point? Because they cannot form hydrogen bond. What is their answer? They do not form hydrogen bond because they not contain any hydrogen. Okay, or have higher molecular mass. Okay, that's it. Next one. Which of the following is used as Hinsberg reagent? What is Hinsberg reagent? Hinsberg reagent is benzene sulfonyl chloride. Benzene sulfonyl chloride. What is the structure? Benzene sulfonyl chloride. Short form we can write. What is this? C6H5 SO2Cl. Where is that? C6H5 SO2Cl? Option A. What is the purpose of Hinsberg reagent? It is used to distinguish between primary, secondary and tertiary amines, right? Question number 11. Anilinium hydrogen sulfate. What is this? You studied like this one. When aniline react with a fuming H2SO4 or sulfonation, H2SO4 contain H plus and HSO4 minus. So the aniline take the, by using the lone pair, take this H plus, you get anilinium. What is anilinium? NH3 plus and HSO4 minus. Anilinium hydrogen sulfate. This on heating, you know, it converted to what? Sulfanilic acid, NH2 and SO3H. That is called a sulfanilic acid. Sulfanilic acid. So read the question, all of you. Anilinium hydrogen sulfate, when heated with the sulfate on heated with H2SO4 at 543 to the 453 to 473 Kelvin produces what? We get sulfanilic acid. So aniline on treated with H2SO4, first we get anilinium hydrogen sulfate. You studied this reaction under sulfonation, right? And this on heated you get sulfanilic acid. Question number 12. When aniline is heated with a concentrated H2SO4, it form. Aniline is heated with a concentrated H2SO4. What is H2SO4 contain? Just to be discussed, H plus and HSO4 minus. What we get initially? Initially we get NH3 plus and HSO4 minus. Later on heating becomes sulfanilic acid. But sulfanilic acid is not given here, so we can go with which one? Anilinium hydrogen sulfate can form. Same question. Now, amines have, they're all amines, the basic property while you're reading from NCERT, you may see that amines having a fishy odor, fishy smell. So that's a general property of amine, amines having fishy odor. Just remember. What is the best reagent for converting 2-phenyl propanamide? What is prop? 3 carbon. Amide means CONH2. So 1, 2, 3. 1, 2. So 2 second position phenyl ring. So this compound 2-phenyl propanamide into 2-phenyl propanamine. Okay. 2-phenyl propanamine. What is the best reagent to convert 2-phenyl propanamide to 2-phenyl propanamine? Is there any change in number of carbon? I think no. This is an amide, and this is a amine. If you want to reduce one carbon, then we can use Hofmann bromamide. But here there is no reduction in carbon number. So if you want to convert a amide into amine, we have the reducing agent. What are the reducing agents to convert amide into amine? Basically, we are using LiAlH4, lithium aluminum hydride, followed by hydrolysis. So where is this LiAlH4 is mentioned? Yes, LiAlH4 is there. The best reagent to convert amide into amine without change in carbon is LiAlH4. Okay. Now, aniline is used. What is the application of aniline? They're all aniline. I think that's the chapter, the final part you may studied. Aniline is used. Aniline when undergo coupling reaction with the phenol and the benzene diazonium chloride when react with aniline and phenol, we get dyes, orange dye and yellow dye, right? So aniline basically used in dyeing industry for coloring agents. Next one, an organic compound A on reduction. What do you mean by reduction? Addition of hydrogen gives a compound B, which on reaction with the chloroform, CHCl3 chloroform and potassium hydroxide. What is this reaction? That is our carbylamine reaction, giving a compound C. The compound C on catalytic reduction means hydrogen with a palladium or nickel, gives a N-methyl aniline. What is N-methyl aniline? Benzene with a NHCH3, N-methyl aniline. The compound A is, okay, let's make a back calculation. Is it a secondary amine or not? Yes. If you want to get a secondary amine by reduction, it should be an isocyanate, NC. You know, cyanide on reduction, you get primary amine. Isocyanate on reduction, we get secondary amine. So it's an isocyanate. Yes, we know carbylamine reaction mean isocyanate is the product. So what should be B? It should be aniline. You know, aniline on carbylamine reaction become isocyanate. If you want to get aniline by reduction, what should be this? It should be nitrobenzene, because nitro group on reduction we get aniline. So what is the overall answer? What compound A is which one? Nitrobenzene is the compound A. Clear, my dear students? Okay, next one. The compound obtained by heating a mixture of primary amine, okay, a primary amine reacting with the chloroform and alcoholic KOH. Yes, what is this reaction? Chloroform and KOH is there, mean carbylamine reaction. Foul smell. What is the foul smell? Isocyanate. We get isocyanate, right? Isocyanate. So they started from primary amine. So what we get? A alkyl isocyanate, right? Alkyl isocyanate. Not halide, not amide, right? So when amines react with the chloroform and KOH, we get always the isocyanate is the product. Alkyl halide. What is alkyl halide? RX. On treated with the KCN, followed by reduction. Reduction means hydrogen with any catalyst, leads to the formation of which one? Tell me all. Primary haloalkane when react with the KCN, we get cyanide, right? KX cut, you get RCN. Cyanide on reduction, we get what? Primary amine, RCH2NH2. CN become CH2NH2. So what is the answer? RCH2NH2, that is option B, RCH2NH2. Right? Simple reaction. Which of the following does not react with the Hinsberg reagent? You know the observation. Primary amines react with Hinsberg reagent, you will get a precipitate which is soluble in alkali. Because it is contain acidic hydrogen. Secondary amine also react with the Hinsberg reagent, you will get a product which is insoluble in alkali, is the observation. Next, whereas tertiary amine do not react with the Hinsberg reagent because no hydrogen present in tertiary. So question, which of the following does not react with the Hinsberg mean? They are asking you which is a tertiary amine. Which is a tertiary amine? C, because it contains N alone, right? Because or N connected to 3-methyl group, it's a tertiary. That's it. 20 question above, what is Z? This is ethyl amine. Ethyl amine on diazotization, what we get? C2H5 N2Cl, diazonium salt. Diazonium salt when treated with bromine. Diazonium salt treated with which one? Bromine. So what is that? Bromine with red phosphorus is given. So basically the reaction you can understand from the ammonia. So ammonia means what? Ammonia means what? Excess they are using. So what is that? Ammonolysis is there. So C2H5 N2Cl with the bromine, if you are excess you are using, you will get C2H5 Br, where excess ammonia if you treated, what happened? H and Br will cut, you will get C2H5 NH2. We studied if you use excess ammonia in ammonolysis, the primary amine will be the major product. So C2H5 NH2 is what? Ethanamine, right? Ethanamine. So ethanamine, that's actually ethanamine started, we got ethanamine back, right? So ethanamine on diazotization, what we get? Actually diazonium salt. You know this diazonium salt is highly unstable. since studied aliphatic diazonium salts are highly unstable, so immediately it react with which one? Water form what? Alcohol. Actually, this alcohol is reacting with the bromine and phosphorus, we get bromoethane, then ammonolysis, we get primary amine. This this reaction is from the, this step is from the haloalkane chapter. Alcohol when react with the bromine and red phosphorus, we get haloalkane. Now, which of the following when heated with a mixture of ethanamine and alcohol? What is ethanamine? Ethanamine is C2H5NH2. Ethanamine. What is alcoholic potash? Potash means potassium hydroxide. Okay. So alcoholic potassium hydroxide gives ethyl isocyanate. Gives ethyl isocyanate. So what is this reagent? If you want to get isocyanate, what is the product? What is the reaction? Carbylamine reaction. In carbylamine reaction, the amine react with alcoholic KOH and what? Chloroform. What is chloroform? CHCl3. What is chloroform? IUPAC name? Trichloromethane. What is that? Trichloromethane, option C. Trichloromethane. See, it's the same reaction they are asking in different mode, right? So whenever a amine react with alcoholic KOH and chloroform, then only we get what? Isocyanate. So they're asking which is the missing one? Chloroform. Chloroform is trichloromethane. 22. Which of the following pair species will yield carbylamine? Remember, carbylamine test is given by primary aliphatic or primary aromatic amine. Remember, that means basically they should contain NH2 group. Check it all. See, this CH3, CH2, Br and KCN, you get cyanide, right? You will get, what is the product? You will get CH3, CH2, CN. No, cyanide is not the one giving carbylamine. Amine should form. What happened when bromoethane react with the excess ammonia? Excess ammonia, if you are using, primary amine will be the major product. So you will get CH3, CH2, NH2. Yes, this is a primary amine. It can give carbylamine test. We know AgCN, if you are using it, isocyanate, you studied in which one? Which reaction? Our haloalkane reaction, right? Which of the following pair of species will yield carbylamine? So carbylamine test. Which of the following pair of species will yield carbylamine test? So here actually the product is what? CH3CH2NC. CH3CH2NC. So carbylamine, if they ask the questions like which will give, which is very close to the reaction of carbylamine test, mean we can go with which one? C. Right, because in carbylamine reaction, what is the product? Isocyanate. Even if you treat it with AgCN, you will get the product what? Isocyanate. But here the question, which of the following pair of species will yield carbylamine? So carbylamine what, my dear? Carbylamine means isocyanate, okay? Yes, carbylamine means isocyanate. So who give isocyanate is the question. So let's go with option C is the correct answer. Clear? Who will give carbylamine reaction means we can say primary amines are giving carbylamine reaction. So you can go with which one? Option B. But here, which of the following pair of species will give you carbylamine? Carbylamine means isocyanate. So isocyanate is getting from third reaction. Okay? Careful. 23. The compound is given as C6H5. This is C6H5, CONHCH3. This can be converted into C6H5, CH2, NHCH3 by which reagent? What is this reaction? This is a amide to amine. See, amide to amine without change in carbon. So amide to amine without change in carbon, already we discussed LiAlH4 is the best, right? LiAlH4 is the best to convert a amide into which one? Amine without any change in carbon. Next question, benzene diazonium chloride when treated with the CuCN, we get cyanobenzene with the nitrogen and CuCl. The above chemical reaction is associated with which of the following name? CuCN basically we are getting from the Sandmeyer reaction, right? Basically we are getting through Sandmeyer reaction. But here they said nitrogen and CuCl is the byproduct. Basically Sandmeyer mean nitrogen is the byproducts we are getting. So anyway, Getterman, sometimes they give you some Balsheman, you studied already to bring which one? Fluorine. Getterman reaction is what? That's also we can use it, but that's copper powder we are basically using. Then Fittig reaction is to prepare biphenyls, and Sandmeyer is the one. What is the basic reagents we are using for Sandmeyer? We are using Cu2Cl2 along with which one? HCl, Cu2 Br2 along with which one? HBr, and CuCN along with which one? KCN. These all are what belongs to which one? Sandmeyer reaction. Now the reaction of aniline with benzoyl chloride. What is benzoyl chloride? Benzene with COCl. Benzoyl chloride gives what? We can directly write the product here since it is MCQ. Very simple. Take this H and Cl, cut. So we will get the compound benzene with NH connected to CO, one more benzene ring. What is this product is called? N-phenyl. N-phenyl, benzene with an amide. What we call? Benzamide. N-phenyl benzamide. Is it there? N-phenyl benzamide is not mentioned. That is also called benzanilide. Benzanilide. N-phenyl benzamide is completely called what? Benzanilide. Question. The same one question already we discussed in part 1. The hybrid state of nitrogen is in. Okay. The hybrid state of nitrogen in R2NH. What is R2NH means? Secondary amine. We discussed this question before, that is sp3. If they ask questions based on the hybridization of amines, basically it will be sp3 because amines are derived from ammonia. Ammonia is sp3 hybridized. Therefore, already we discussed in part 1. So this is the hybridization of amine, sp3. Next one, which of the following is the strongest base? If they ask you about the strongest base, we know that aromatic amines are very less basic. Because in aromatic amine like aniline, the lone pair on nitrogen is involved in resonance. So it's not available for protonation. See all, the nitrogen is on benzene, so it's aromatic. Here nitrogen on benzene, aromatic. Here nitrogen on benzene, aromatic. But here nitrogen not on benzene, it's an aliphatic, my dear. Aliphatic amines are the strongest base than aromatic amines, right? So aliphatic amine is the most. Now among the following, which is the weakest base? Weakest base means aromatic. Check which is aromatic. Here nitrogen not on benzene ring. Here nitrogen not on benzene ring. Nitrogen not on benzene ring. But what is this? What is this? What is this? These all are aliphatic amines. What is this? CH3, CO, NH2. It's an amide, my dear. This is an amide. Keep in mind, amides are weak base than amines. Amides are weak base than amine because the lone pair in amide involved in resonance. So the lone pair is not available for protonation. Remember, basicity order when asking, amides are weaker base than amines. Okay. So we can go with option D. Amides are weakest base. Next one, among the following, which is the most basic compound, most basic? They're all aniline. What is aniline? Aniline is aromatic, right? So cut it. What is acetanilide? Acetanilide means benzene with NHCO, CH3. See, the lone pair is involved in resonance. Cut it. Amides also least. Para-nitroaniline, that also contain aniline, less. What is benzyl amine? What is benzyl amine? Benzyl mean benzene with the CH2, NH2. See, the nitrogen is not on benzene ring, so the lone pair is available for donation. Therefore, aliphatic amines are more basic. Let's go with option A. Clear, my dear? Next one. Aniline in a set of reaction yielded a product D. What is the last product? D. Let's start. First structure is what? This is aniline on diazotization. What we get? The aniline on diazotization, diazonium salt. Diazonium saltron treated with the CuC undergoes Sandmeyer reaction. You get cyanobenzene. Cyanide on reduction. What we get? Aniline means amine. CH2, NH2. You know what is this? HNO2 is called nitrous acid, right? This is an aliphatic amine on diazotization. You know it becomes the salt CH2, N2 plus Cl minus. We know aliphatic diazonium salts are highly unstable, so immediately it react with the water. That they won't give you, okay, we should perform. Aliphatic, this is not aromatic, right? Because nitrogen is not on benzene. Aliphatic diazonium salt immediately react with the water and form what? Alcohol, CH2OH. What is this compound called? Benzyl alcohol. So we get option A, C6H5CH2OH. Remember, if it is aromatic diazonium salt, that means N2Cl, benzene diazonium chloride, it is highly stable due to resonance. But this is unstable, so immediately react with the water form alcohols. So end with alcohol. The correct order of increasing basics nature for the bases. So one is given ammonia. Ammonia, it's a primary amine and it is a secondary amine, and methyl is the group present. We know the order is aliphatic amines are more basic than ammonia. Ammonia is more basic than which one? Aromatic amines. Basically, aromatic amines are least basic. Correct. Or increasing order, okay? Increasing order. Start. So these are the aliphatic amine, right? You know, in aliphatic amine, more the alkyl group, more basic. So which one? This is more basic one, more alkyl group. So C is the most one. Then which one? B, and least one A. So where is the option? Ammonia, methanamine. Yes, option D. Correct order of increasing basic strength. So more the alkyl group present, you know, more the basic character, right? So therefore this one, then this, and then ammonia. Next question. Which is most basic? So basicity is a repeated question for exam ID. This is amine chapter. Amines are basic. Which is most basic? Dear all, this is aromatic, leave it. This is also nitrogen connected to benzene, aromatic. Yes, C is what? Aliphatic. Oh, no. This is aliphatic, this is also aliphatic. Here more alkyl group is there. More the alkyl group, more donating group, more plus effect, more the basicity. So let's go with option D. The amine that does not react with the acetyl chloride. What is acetyl chloride? Acetyl chloride is CH3COCl. The one which we are using in Friedel-Crafts acylation, right? This is called acetyl chloride. So the amine that do not react with acetyl chloride, this is very simple. Normally amines when react, the Cl react with the hydrogen which is present in amine. So which amine do not react with the benzoyl chloride means the one which do not contain hydrogen. Which one do not contain hydrogen? Tertiary amine. See, on the nitrogen, no hydrogen. Tertiary amine cannot react with the acid chlorides. Okay, because there is no hydrogen to react with the chlorine. Next one. Aniline is less basic than. So they're asking you which is most basic among this one. Triphenylamine. What is triphenylamine? 3-benzene ring group, right? 3-triphenylamine. See, it is very less basic because more amines are there. I think option 2, my dear, this is what? Benzyl amine. What is benzyl amine? CH2NH2. It's an aliphatic amine. Already we discussed, it's more basic. See, diphenyl. Benzene ring is there, no? Leave it. Nitroaniline is also aniline. So, aniline is less basic than. So, they're asking you which is more basic. There is an aliphatic amine already, that is benzyl amine. Now, which one of the following is the product that is formed when a primary amine when react with the chloroform and which one? Alcoholic KOH. Yes, what is this reaction? When primary amine react with the chloroform and alcoholic potassium hydroxide, we get isocyanate. Isocyanate, the foul smell, right? So where is isocyanate? Yes, option A, isocyanate. Now the product obtained when methylamine is treated with nitrous acid. What is nitrous acid? HNO2. You know, this is our diazotization process, right? So aniline, amines on diazotization, it becomes the diazonium salt N2Cl. But we studied all of you, this is a aliphatic, right? So this is an alkyl diazonium salt. This is a alkyl diazonium salt. You know, alkyl diazonium salts are highly unstable because resonance and are not possible. So don't stop here. It immediately react with the water. You know, water contain the ion H plus and OH minus. The OH come to CH3, you get CH3OH. Byproduct H plus and Cl minus HCl, and the nitrogen gas come out. So product is what? CH3OH is the product. Where is that? Option 1. So if you are getting a alkyl diazonium salt, please don't stop there. Immediately react with the water, make it alcohol. Okay, that's a stable. Now, secondary amines can be prepared by. What is secondary amine mean? For example, CH3NHCH3. Secondary amine can be prepared by which reaction? Reduction of nitro compound? No. We know nitro compound on reduction we get amine, primary. Reduction of isonitrile. What do you mean by isonitrile? Isocyanide. Yes, dear all. NC on reduction you will get NC. This is the theory I will just tell you. If you have a CH3CN and CH3NC, what is this? Cyanide and isocyanide, right? Cyanide on reduction, you will get CH3, CH2, NH2. Basically, CN become CH2, NH2. It's primary, right? Cyanide on reduction, you get primary amine. But isocyanide on reduction, you get CH3, NHCH3. The NC become NHCH3. What is this? It's a secondary amine. Not at all. Cyanide on reduction, primary amine. Isocyanide on reduction, we get secondary amine. So we can say reduction of isonitrile give you which one? Secondary amine. Now, which of the following is the IUPAC name of the compound in which one hydrogen of ammonia, what is ammonia? NH3, is replaced by an ethyl group. So, one hydrogen they are removing. So, what is one hydrogen removing? It becomes NH2 by an ethyl group. What is ethyl? C2H5. What is the name of this compound? Ethanamine, right? Ethanamine. Where is ethanamine? Option C. Did you get the question? That level of question, type of question. They are asking from ammonia, one hydrogen you are leaving. From ammonia, one hydrogen we are leaving. So, what is left? NH2. And it's replaced by a ethyl group. So, what is it called? Ethanamine, right? Next one. Identify the correct, question careful. Identify the incorrect name of the compound. Let me check the compound. Possible structure, let me tell you. Okay, this is 1, 2, 3, right? I can say it is propan 2 amine because second position amine. What is CH3? CH3 is called, you know, CH3, CH3 I can write like this. What is this group is called? Isopropyl. So it's called isopropyl amine. We can say like that. Or what is the another structure? Okay, then we can check it. Okay. So propan 2 amine we can write it as what? 2 aminopropane. That's also correct. So question, which of the following is incorrect? Isopropyl is possible. 2 aminopropane, propan 2 amine. N-propyl amine is not possible. N-propyl amine, that's not connected to this compound. This is propan 2 amine, right? Which of the following is the correct IUPAC name of the compound? What I'm just expanding. CH3N, CH3, CH3, right? What is the correct IUPAC name of this compound? Any one carbon you take the parent chain. So these are branches. What is this branch? Methyl on nitrogen. So it's called NN-dimethyl. NN-dimethyl, one carbon amine, what we call methanamine. NN-dimethyl methanamine. N-N-dimethyl methanamine, right? Option C. What is the correct IUPAC name of the amine? CH3NH, CH2, CH3. Simple question, it's a secondary amine. How to name this amine, my dear? Take the biggest chain, left side 1 carbon, right side 2 carbon. So ethanamine is the parent chain. So this is a branch. So N-methyl ethanamine, right? N-methyl ethanamine. What is answer? What is answer? N-methyl ethanamine. That is option A, right? N-methyl ethanamine. What is the IUPAC name of this compound? Just to pause the video, find the answer all of you and just watch it. Here, left side ethyl, down ethyl, right side is bute. So, right side is the parent chain. So, this ethyl and ethyl are the branches. So, here nitrogen contain 2 ethyl branches. So, it's called NN-diethyl. NN-diethyl, where is that? That is option C. NN-diethyl butanamine, right? Butane 1 amine, correct? First 42, option B, C. What is this product? Reduction of aromatic nitro compound. Aromatic nitro compound, for example, nitrobenzene. Reduction means what? Addition of hydrogen with what, palladium something. Okay, they're already using the catalyst, which one? Tin and HCl. Yes, we know. Nitro group on reduction, what it become? Amine, right? Amine. So aromatic nitro compound on reduction, we get aromatic amines, aromatic primary amine, aromatic primary amine, option A. 44. Which of the following compound cannot be identified by carbylamine test? Please mark it, all of you. Carbylamine test is given by only primary aliphatic or primary aromatic amine. So which one do not give carbylamine is the question. This is a primary amine. This is primary amine. This is primary amine. What is NH mean? It's a secondary amine, option D. Only carbylamine test is given by primary aliphatic or primary aromatic amine. This is secondary, do not. 45. Which of the following compound react with the NaNO2 and HCl? What is this? Diazotization. 0 to 4 degrees Celsius to give alcohol or phenol. I told you that when you treated with NaNO2 or HCl, or what is this NaNO2 and HCl react together, you get HNO2, nitrous acid. If a species undergo nitrous acid and giving directly alcohol means it should be a aliphatic amine. Which is an aliphatic amine? Primary amine, B. See, what is this compound? C2H5NH2. If you treated with NaNO2 and HCl or HNO2, you get C2H5N2Cl. Do you remember? Alkyl diazonium salt is highly unstable. So immediately it reacts with the water and it becomes what? Alcohol. So that is possible by primary aliphatic amine. Even this primary aromatic amine also, aniline also can undergo diazotization, but it forms a stable compound. It won't give alcohol immediately, right? So therefore option B. Acetylation of a secondary amine in alkaline medium yield. Let me give you an example. Secondary amine, right? Okay, let me take a secondary amine, RNHR. Is it a secondary amine? Yes, NH group is there. Secondary amine react acetylation. What is acetylation? Treating with the CH3CO, OCO, CH3, acetic anhydride. How can we write the product directly during acetylation? Simple. From the amine, take H. From the anhydride, take this part. So what is actually cutting? CH3COOH cut. What is left? RNR, alright, connected to this remaining part. What is remaining part? COCH3. What is the name of this compound? It's called nitrogen contain 2 alkyl group. So it's called NN dialkyl. NN dialkyl ethanamide or amide. Generally amide. NN dialkyl amide. What is CONH is called? Amide. So where is the product, all of you? NN dialkyl acetamide. Yeah, acetamide. Or NN dialkyl amide is there. NN dialkyl amide is anyway not B and D, right? Anyway not B and D because both are amine. During acetylation, we will get what? Amide. So NN dialkyl acetamide or NN dialkyl simply amide. We can say option A because they said clearly it's what? Acetylation. Acetylation, okay, generally we can say even amide also possible. Acetylation means we are adding acetic anhydride. So acetic anhydride when we using, this term is already clear, ethanamide means acetamide. So let's go with option A. Next, the amines are basic in nature, yes. Hence they form salt with hydrochloric acid. You know, amines are basic in nature because they contain lone pair that can easily donate and take the H+, right? Which of the following will be insoluble in dilute HCl? Insoluble in dilute HCl means they are asking you which is weak base. Which is a weak base. Tell me all which is a weak base. This is an aromatic amine. Yes, least basic. This is more aromatic ring is there, very least basic. This is aliphatic. This is also aliphatic. So they are asking you which amine is insoluble in dilute HCl mean which is a least basic. Dear all, what is the option A? Option A is aniline. You know, in aniline, the lone pair is not available. It's involved in resonance stabilization. What is B? What is B, my dear? There is 3-phenyl ring. 3-phenyl ring, okay? 3-phenyl ring. See, the nitrogen lone pair is fully involved in resonance. It's not at all ready to donate the lone pair. So let's go with option B is the very least basic. Therefore, it is insoluble in HCl. 48. Primary, secondary, tertiary amine may be separated by. We discussed only one reaction in this chapter to distinguish between primary, secondary, tertiary amine. What is the reaction? Hinsberg reagent. What is Hinsberg reagent? Benzene, sulfonyl chloride. Already we discussed that. Primary amine, how it behave. Secondary amine, how it behave. Tertiary amine, do not react. Right. Next one. An organic compound X. An organic compound X was treated with a sodium nitrate. What is sodium nitrate? NaNO2 and HCl. That is diazotization in ice cold. Ice cold means 0 to 5 degree. Bubbles of nitrogen gas were seen coming out. What is a compound X can be? So remember, cold condition, the diazonium salt is given by an aromatic organic compound X was treated with a sodium nitrate and HCl in ice cold condition. Bubbles of nitrogen gas were seen out. So let me take a aliphatic system. Okay, anyway, it's a primary amine because diazotization is given by primary amine. Let me take a aliphatic primary amine. For example, RNH2. When we reacted with this reagent, we get what? Rn2 plus Cl minus. We discuss it's very unstable. So immediately it react with which one? Water, form what? ROH, nitrogen and HCl. But if it is an aromatic amine like aniline, that also undergo diazotization, we get diazonium salt. But you know, it is highly stable, it won't give nitrogen gas. So nitrogen gas, if you want to produce, it should be what type amine? Primary aliphatic amine. It should be a primary aliphatic amine should be that. Question number 50, dear all, we are going to 50 question. Among the following, which will have the positive carbylamine test? Come on fast. Carbylamine test is given by primary aliphatic or primary aromatic amine. You know, this is a primary amine. This is secondary. This is tertiary. This is primary. So which will give? All primary amine can give. Okay. So 1 and 4. Where is that? 1 and 4 can give which one? Question which will give the positive test. Okay. So 1 and 4 are primary. They can give which one? Carbylamine test. Clear all of you? Question number 51. Cyclohexyl amine. You know what is cyclohexyl amine, right? This is what we call cyclohexyl amine. Is stronger base than aniline. Yes, correct. Right? Correct. Why cyclohexyl amine is more basic than which one? Aniline. We know cyclohexyl amine is an aliphatic amine and aniline is an aromatic amine. We know very well why aromatic amines are least basic. Because in aniline, the lone pair which is involved in resonance, or resonance what we also call conjugation. So where is the answer? Yes, option A, right? In aniline, the electron pair is involved in conjugation. That means resonance. So since aromatic amines, we know they are less basic in nature because the lone pair is involved in resonance. But here the lone pair is not involved in resonance. So easy to available for protonation. Therefore more basic. Question number 52. The strongest base among the following is, which is the strongest base? Check it whether any aliphatic is there or not. This is aromatic, cut it. This is also aromatic, right? Because it's connected to benzene ring. This is also aromatic, connected to benzene ring. This is what? Aliphatic, because nitrogen connected to an alkane chain, right? So dear all, once again I am reminding you, benzene contain all compounds are not aromatic, okay? If nitrogen directly on benzene, then only it's aromatic. What is the last compound? Last compound is benzyl amine, where nitrogen is not on benzene ring. So the lone pair is available for protonation, easily basic. So strongest basic is D. Question number 53. Reduction of, what is the compound? CH3, CH2, NC. What is this? Isocyanide, right? Okay. with hydrogen in presence of nickel or platinum catalyst, what it give? Already discussed in the part 2 session. Cyanide on reduction we get primary amine, isocyanide on reduction we get secondary amine. So what is the product? CH3, CH2, NC become NHCH3, right? It's become secondary amine. Where is the answer? CH3, CH2, NHCH3, option B. Remember all, cyanide on reduction primary amine, isocyanide on reduction secondary amine. Okay, notice. Next one, which of the following is not a primary amine? Not a primary amine. What is meant by primary amine? They basically contain what? NH2 group, right? Okay. For your reference, I am just giving the compound structure. What is meant by tert-butyl? Tert-butyl means one carbon connected to 3-methyl group is called tert-butyl with amine. See, it's primary. Option B is given sec-butyl. What is sec-butyl? CH3CH2, CHCH3. This is called sec-butyl with amine. This is also what? Primary. Option C is given isobutyl. What is isobutyl? You know, this is called isopropyl with one more carbon is called isobutyl amine. That is also primary. What about D? Dimethyl amine. That means 2-methyl group in between amine. See, this is a secondary amine. So, which is not a primary amine? That is option D. Clear all of you? Okay. Next. Which of the following is aromatic amine? Aromatic amine means the nitrogen should be on benzene ring. See, this is aromatic, right? Because nitrogen on benzene. This is also aromatic, nitrogen on benzene. This is not aromatic because nitrogen not on benzene is aliphatic. So we can say both A and B are aromatic in nature. Clear? What is the IUPAC name of the compound? C2H5 twice NCH3. Let me write. What is C2H5? CH3CH2. N, one more CH2CH3 and then one CH3 is there. Okay. Question, write the IUPAC name of this compound. What is IUPAC name? Take the parent chain first all. See, left side 2 carbon, right side 1 carbon, 2 carbon. So 2 carbon is the biggest chain. Let me take this the parent chain. So this is ethyl branch, this is methyl branch. So ethyl or methyl, which one we write first? Ethyl, right? So we can say N-ethyl, N-ethyl, N-methyl, N-ethyl, N-methyl, ethanamine, right? We can call ethanamine, right? Ethanamine. So what is the name? What is the compound? N-ethyl, N-methyl, ethanamine. That is option C. Question 57. Okay, not wasting your time, but just to keep practicing the question, all of you. Next question, carefully listen all. This is a ketone and this is chlorine. What is the function of KCN? KCN convert chlorine into cyanide. So what we get? Cyclohexanone. This one Cl become Cn. Cyanide on reduction. Cyanide on reduction. What Cn become? Cn converted to CH2NH2. Right? Cyanide become primary amine. So where is that product, all of you? I think it's option B, right? Yes. Cn is there. Cn becomes CH2NH2. Clear? Simple reaction. Now, which one of the following reducing agent likely to be the most effective in bringing about the following change? What is the change? It is an amide. An amide converted to amine without any change in carbon. What is the best reagent we discussed? LiAlH4, right? LiAlH4 is the best reagent to convert amide into amine without any change in carbon. Next one. Which is the end product in the following? What is this? Carboxylic acid. Carboxylic acid when treated with the PCl5, what happened? What is the basic function of PCl5? The OH converted to Cl. So we get benzene with COCl called benzoyl chloride. When acid chloride treated with ammonia, what happened? One H, one Cl cut. We get amide. We get benzene with CONH2, benzamide. Benzamide on Hofmann reaction, CO group cut. What we get? Final product is what? Aniline, right? Final product is what? Aniline. So what is the reaction once again, my dear? They given you carboxylic acid when treated with PCl5, SOCl2 and all, the OH part becomes Cl. This is called benzoyl chloride, and treated with ammonia, it's called what? Ammonolysis. We get like ammonolysis, we get which one? Amide. So like it's just like simple. So chlorine and NH hydrogen is removed, like the ammonolysis process. Amide on Hofmann reaction. If it is Hofmann, cut CO group. Finish. So product is what? Aniline. Next, amine that cannot be prepared by Gabriel-Thalamide synthesis. Through Gabriel-Thalamide synthesis, we can't prepare which one? Aromatic amines. So they're asking you, which is an aromatic amine? Which is aromatic amine? Aniline. Methylamine is aliphatic, benzylamine is aliphatic, isobutyl aliphatic. Through Gabriel-Thalamide synthesis, we can't prepare primary aromatic amine. We can't prepare, therefore, aniline. Which one of the following amide will give ethyl amine on reaction with the sodium hypobromide? What is sodium hypobromide? NaOBr. That is nothing but our NaOH and Br2, Hofmann bromamide, they are asking dear all. So what is the product already given? Ethyl amine. What is ethyl amine? CH3, CH2, NH2. If you want to get ethyl amine through Hofmann, what should be the amide? Propanamide. One carbon should be extra, right? CH3, CH2, CONH2. It should be propanamide. You know the CO group cut, we get this amine. So what is the product? Which one of the amide can be used to get ethyl amine? We can use propanamide, option B. If you start with the propanamide, you get which one? Ethylamine or ethanamine. You know the speciality of Hofmann reaction, one carbon always less in the product. Next, which of the following has highest pKb? Highest pKb means very least basic. Highest pKb means least basic. Come on all, which is least basic? This is what? This is aliphatic. Ammonia is the answer. Ammonia is the answer. Because you know aliphatic amines are more basic than ammonia. Ammonia is least basic. So least basic means highest pKb. Okay, fine. Next one. Most basic species among the following. Which is most basic? You know this is aromatic. Even this lone pair also can involved in resonance. Aromatic, like aromatic type. Lone pair not available. These are what? Aliphatic. Among these two, which is more? Dear all, this is primary, right? Because NH2. What is this? Secondary. Among primary and secondary, basically secondary will be always more basic. Why? Because it contains more alkyl group. More donating group mean more basic. Okay. So option D is the most basic in nature. So whenever they ask most basic mean, first you cut the aromatic. Because aromatic amines are least basic. Aromatic amine cut. Among aliphatic were basically more alkyl group, more basic. Next, what is the correct order of the increasing basic strength? Okay, carefully listen all are aniline. But you can see here there is a nitro group. You know nitro group is a withdrawing group. Alkyl groups are donating group. Alkoxy is also donating group. And nitro group is a withdrawing group. Okay, we know the general order. Donating group if there, that will be more basic, right? So third and fourth one is more basic. Among third and fourth, which is more basic, remember all of you, methoxy group is more donating than methyl group, because you know the oxygen contain what? Lone pair. Methoxy group is more donating, so more basic. So no doubt fourth one is more basic. So either we can cut this one, either A or B. After fourth one, of course, definitely third one, because that is the next donating group. Okay, fine. Next one, we can go with the first one, because that nothing now contain electron withdrawing group. Careful about the last point, my dear. This is a withdrawing group. It is in para position, and here the withdrawing group is in meta position. With respect to the NH2, this is para. With respect to NH, this is meta. Remember all, if the group is present on para position, its effect will be more. So here the nitro group is in para, it acts as a very strong withdrawing group, so that will be the least basic. So second is the least basic, that is only option A. So what are the point here? More the donating, if the donating group present, more basic. Withdrawing group present, least basic. Next, the most basic amine from the following. Dear all, this is aromatic. This is what? Aromatic. All are aromatic here. All are aromatic. And what is the difference here? Nitro group, withdrawing group. Alkyl group, donating group. Nitro group, withdrawing group. Halogens are withdrawing group. Question, most basic. Most basic means the one with donating group. Which one? Option C. Okay. Next one. Basic strength of different alkyl amine depend upon in aqueous solution is. In gaseous state, we studied in classes like this one. In gaseous state, the order for basicity is tertiary greater than secondary greater than primary because we consider only plus I effect. More the donating group, more plus I effect, more basic. Therefore, tertiary highest in gaseous. But in aqueous state, we study two cases, my dear. If methyl group the present, the order is secondary, primary, tertiary. If ethyl group present, then secondary, tertiary, primary is the order. There is a reason why in aqueous state the order comes like this, because in aqueous state we have to consider plus I effect, solvation effect, sterific effect all together. So D is the correct answer. In aqueous state, why the order come like this one? We can able to say that in aqueous state we have to consider total 3 state, my dear. Plus I effect, steric effect and solvation effect. Therefore, the order comes like this one. Next one, arrange the following compound in increasing order of basicity. So, this is aliphatic, ammonia, aromatic. Remember all, we have the general order. Aliphatic amines are more basic than ammonia, then only aromatic, right? Okay, then we can able to say like this. If methyl group comes, see, this is one methyl group, this is two methyl group. More the donating group, more basic. So no doubt this is more basic among these two aliphatic. So this is most basic. I think that is only one option, C. So this is most basic, then this one. Then only ammonia, then only aromatic. Okay, very simple. Next one, yes, complete the reaction. What is the final product? Let me start from here. Everyone carefully listen. What is this product? Para-toluidine. Para-toluidine when treated with, okay, let me start here. So, this is what NH2 and CH3. What is mean by AC2O? AC stands for acetate. So, what is AC2O? CH3CO, OCO, CH3. Acetic anhydride is the short form AC2O. Sometimes, you know, during exam, they will mention like this with the pyridine. So, this is what acetic anhydride, this is just elaborated form. What happened? Aniline react with acetic anhydride, that is called acetylation. You will get, take this H and this part, this you remove it. CH3COOH, remove it. So, what is left in the system? CH3 is already there in para, it become NHCO, CH3, it become acetanilide. You know, amines are very strong ortho-para group, amides are weak ortho-para. So, now they are doing bromination. So, now they are doing bromination. So, where the bromine can go, either ortho or para. But here, para is already occupied by methyl. So, only the allowed place is ortho. So, let me place one bromine on the ortho position. We get one bromine here, already one CH3 is there. Finally, when they treated with the water in presence of acid or base is there, the amide group back to amine. The amide group back to amine. So, we will get Br here, CH3 here. Yes, where is the product, my dear? Check it all. NH2, Br, CH3, that is option C. So, first step is acetylation, then bromination. Bromine, if you add, either it should go to ortho and para. Here para already CH3 is there, therefore I placed on ortho. So amide on hydrolysis and H plus directly back to amine. Okay. Question number 69. Primary amine react with the benzoyl chloride to give what? Primary amine. Let me take an example, RNH2. Primary amine. Treated with the benzoyl chloride. What is benzoyl chloride? Benzene with the COCl. We studied amines when react with the acid chloride or acid anhydride, we get amides. How we get amide? Very simple reaction. Take one H, take this Cl. HCl cut. Join the remaining. R, NH, C double bond O, benzene ring. You're getting R, NH, CO, benzene ring. What is this? Amide. You get amide. Which amide? Benzene with amide, what we call benzamide, right? Benzamides. Next one. Primary and secondary amine react with acid chloride or acid anhydride to form what? Just to discuss now. It's a primary amine. When reacted with the acid chloride or acid anhydride, what we get? We get amides, substituted amides, right? We can say, see, these alkyl groups are get substituted, right? That is called substituted amides are formed. Anyway, this is enough. This is enough. Remember, when amines react with acid chloride or acid anhydride, they form what? Amides. Okay, remember, amides. Next one. Which of the following species are involved in the carbylamine test? What is carbylamine test? Take a primary amine reacting with what? Chloroform and alcoholic KOH. What we get? Isocyanide along with the KCl and H2O. This is called what? Foul smell isocyanide test or carbylamine test, right? Question. Which of the following species are involved in this one? See, isocyanide is there or not? Yes. Chloroform is there or not? Yes. COCl2, what is this? Carbonyl chloride is not required here. NaNO2HCl, not required here. So, what is that? 1 and 2 are possible. 1 and 2 only. Clear all of you? Which of the following, whether you know the reaction, that's a checking one. Next. Which of the following will form isocyanide on reaction with the chloroform and KOH? Remember, isocyanide test or carbylamine test is only given by primary aliphatic or primary aromatic amines. Question. Which of the following will form? So check it. This is NH, right? It's a secondary. Cut it. This is also secondary. Cut it. This is what? Primary. Yes, it can give. This is what? Tertiary. It cannot give. Right? Carbylamine test or isocyanide test is given by primary aliphatic or aromatic amines. Next one. Which amine among the following will answer positively with the carbylamine test? Again they are asking you which is a primary amine. Primary amine, how can we find? Check NH2 group is there or not. Where is NH2? This is NH, secondary. NH, secondary. NH2, yes, primary. N alone, tertiary. Same, right? Same question. So, which will give carbylamine test mean primary. Primary, they contain NH2 group. 74th question, my dear. Question is, I'm starting. When para-toluidine, what is para-toluidine? You know, aniline and toluene mix is called para-toluidine, right? Para position. Para-toluidine react with the chloroform. What is chloroform? CHCl3 and alcoholic KOH. Then what is the product? You know, this is carbylamine reaction. During carbylamine, NH2 becomes what? NC. That's it. NC, CH3 remain as it is. So what is the product? Where is the product? Where is the product? That is option B, right? Okay. Para-toluidine when react with the carbylamine, it form isocyanide. Question number 75, my dear. The action of nitrous acid. What is nitrous acid? HNO2. That is our diazotization. On an aliphatic primary amine give. Carefully listen on. You know, aliphatic amine, I can write it as RNH2. When it undergo diazotization at a 0 to 5 degree, the NH2 becomes what? Salt N2 plus Cl minus. We know alkyl diazonium salt is highly unstable. So immediately it react with the water in the medium. You know, H2O contain H plus and OH minus. So R combined with OH, you get ROH as the main product. What is this? Alcohol plus H plus Cl minus, you get HCl plus nitrogen gas come out. So overall we are getting alcohol. Where is alcohol? Option C. So when amine react with the primary amine react with the nitrous acid, it end up to alcohol. So alcohol will be the final product. So what is the end product Z in the following reaction? Starting with the ethyl amine. What is ethyl amine? CH3, CH2, NH2. Ethyl amine when reacted with the HNO2. I think we stop the last question from this one. When a aliphatic amine react with the nitrous acid, it forms salt, but it's unstable. It immediately react with the water, form alcohol. So ethyl amine give you what? Ethanol, CH3CH2OH. Ethanol when react with the PCl5, you know, OH converted to Cl, CH3CH2Cl. What happened when treated with the KCN? You know, cyanide, yes, we get CH3CH2CN. What is the name of this cyanide? You can say ethyl cyanide. You can call ethyl cyanide, or in terms, you know, cyanide is also called a nitrile, right? So in terms of nitrile, how can we say 3 carbon total? So it's called propane nitrile, propane nitrile. So question, what is the final product? We can say option A, propane nitrile. You know, cyanide is also called a nitrile, right? So this is called ethyl cyanide, or total 3 carbons, so propane nitrile, right? Question number 77, identify X and Y in the following reaction. Okay, starting with the amide, CH3CH, CH3CONH2 is given. One amide is given. They are performing Hofmann. Hofmann reaction means what? Cut the CO, finish. We get CH3, CH3, NH2, fine. Then this is the compound X. Now they are treated with what? HNO2. What is HNO2? Nitrous acid, my dear. This is aliphatic again. Aliphatic amine when react with the nitrous acid directly write its alcohol. You get CH3, CH3OH, isopropyl alcohol or propan2ol. So where is this product, all of you? I think it's option C, right? CH3, CH3NH2, CH3, CH3OH, right? That's it. Question 78. Which of the following statement is not true? First, dimethylamine is a stronger base than trimethylamine in aqueous state. In aqueous state, we studied if methyl present, secondary, primary, tertiary is the order. Yes, this is secondary, correct. Secondary amine show carbylamine reaction. No carbylamine reaction only given by primary amine. So option B is the correct answer, right? Question, which is the statement is not true. Secondary amine show carbylamine. No, only primary amine. Nitrogen gas is evolved when ethyl amine is treated with nitrous acid. Yes, we discussed. Primary amine can show carbylamine. Correct. Option B. Which of the following amine does not react with Hinsberg? We know Hinsberg reagent, if you treat it with an amine, there is no reaction, mean it should be a tertiary amine. Which is a tertiary amine? Option C. Tertiary amine easy to find. N, right? So dear all, once again, NH2 if there, primary. NH alone, secondary. N alone, tertiary. That's it. So tertiary amine do not react with the Hinsberg. This is primary, this is secondary. Only tertiary do not react. Electrophilic substitution of aniline with the bromine water. Yes. We know aniline is a very strong ortho-para directing group. If you directly add bromine water, the bromine go to all of its ortho and para position. So it becomes 1, 2, 3. 3 position. What is this position? We can say 2, 4, 6 tribromoaniline. 2, 4, 6 tribromoaniline form. Remember, aniline is a very strong ortho-para directing group. When it react with the bromine water directly, it's reacted to give 2, 4, 6 tribromoaniline. Amino group is ortho-para directing for electrophilic substitution, yes. But on nitration, the major product is meta-nitroaniline. We know very well. Aniline is very strong ortho-para. What is the nitration process? Nitration process, we are using concentrated HNO3 and concentrated H2SO4. That is a very strong acidic medium. So here what happened? When aniline contact with an acid, it immediately form a salt. What is a salt? Benzene with the NH3 plus. What is benzene with the NH3 plus is called anilinium ion. Anilinium ion. Aniline is ortho-para directing group, but anilinium ion is a meta-directing group. Therefore, you are getting you may study the process like this one. When aniline on nitration, directly, you will get 3 products. You get para product around 51%, meta around 47%, and ortho around 2%. So why aniline is actually an ortho-para directing group, so it should give only para and ortho. Why it's giving meta product around 47%? Because aniline react with the acidic medium form anilinium ion. It is a meta directing group. Therefore, you're getting meta product. So where is the answer is this one. Aniline gets protonated. Protonated means taking H plus with a strong acid to give anilinium ion, which is meta directing. No doubt option A is the correct answer. Next, how aniline can be converted by efficient procedure to mononitro derivative? We studied the procedure like this one. Aniline is a very strong ortho-para directing group, very strong. So we want to make it weak first. If you directly add nitration, we studied the para, meta, ortho, all of them get. We want to get mononitro, that means only one nitro. What is the procedure? First, we will protect the NH2 group by the process called which one? Acetylation. During acetylation, we are using, pyridine. Pyridine is a base which is used to neutralize the acid byproduct. So what is the product when aniline undergo acetylation? We get NHCOCH3. We get acetanilide. We get what? Acetanilide. Dear all, during acetylation, amines are converted to amide. Amide is weak orthopara. Now we can do nitration. Nitration means what? Nitration means we can use concentrated HNO3 and concentrated H2SO4. So nitro group can go to para and ortho, where para is the major one, right? So we can write like this one, NHCOCH3 and one nitro group here. Now we want to get our amine back. They said mononitro derivatives of aniline. So how to get this amine back to amide? So amide back to amine, we can use acid or base, we can use it. We get the amine back. It will become NH2 and nitro group. So they're asking, in order to prepare mononitroaniline, what are the procedure we have to do it? Check it all. Nitration directly, don't do that. Aniline with a dimethyl, nothing. Aniline to acetanilide, then ortho para nitro acetanilide, then hydrolyzed. Yes, option C. First aniline on acetylation become acetanilide. Then I told you if you add nitro, it go to ortho and para, where para is the major product. Then hydrolysis, acid or base you treated, you get the product. Next one, identify the reagent for the following conversion. This is benzene diazonium chloride. If you want to get iodobenzene, what is the reagent we used? Warm Ki. So first one we can use the warm Ki. Okay, so either option A or C. This already ready, right? Not I2. That's also option C is the correct one. Yes, that's it. Warm Ki. Benzene diazonium chloride to cyanide. What we can use is CuCN. That's a Sandmeyer reaction. Diazonium salt, how you can convert into OH? That we can use warm water. Warm water. So that's option C only. So diazonium salt is very important here. All many reaction we studied there. Please go and study it. Okay. The structure of product X. What is this X in this reaction? Let us check it all. Let us check it all. Remember, there is a methyl group, nitro group, and aminone. What they are treating first? First NaNO2 NHCl, which means what? Diazotization. What happened on diazotization? The NH2 become N2Cl salt. CH3NO2 acetes. What is the function of H3PO2 hypophosphorus acid? It convert the diazonium salt completely to benzene. Means overall this group vanish. So you will get the product benzene with CH3 and NO2 alone. Where is that? Where is that? Option A. What is the first process? First process diazotization, NH2 become N2Cl. Second step, if you treat it with H3PO2 and water, the diazonium salt completely vanish. So that benzene and the CH3NO2 will be there. Fill in the blanks with appropriate choice. Okay, let us go for the reaction, everyone. See that carefully. Aniline directly if you do bromine water. We discuss. Aniline on which directly if you add bromine water, you get 2,4,6 tribromoaniline. Aniline on diazotization. On diazotization, NH2 become N2Cl. Bromine acetes. What happen if you treat it with a Cu2Cl2? That is our Sandmeyer reaction. N2Cl become chlorobenzene. Yes, we get Cl and bromine, bromine, bromine. Where it is? Where it is? Where it is, that's clear, very clear from option B itself. Only 3 bromine is getting from here, right? N2Cl and chlorine. Finish all? Simple reaction? Yes. Question number 89 for you. What is the end product here? What is C6H6? C6H6 is nothing but benzene. What happened benzene on nitration? You will get nitrobenzene. What happened nitro group on reduction with the tin and HCl? Become aniline. What happened aniline on diazotization? It become diazonium salt, N2Cl. What happened diazonium to salt treated with H3PO2 and water? It become benzene. Finish. So what is the final product, my dear? Benzene is the final product. So study the reaction. Okay, study the reaction. Next one. The product D. See, this all giving you some idea about the reactions. Okay. So again, aniline on aqueous bromine, you get NH2 Br. Diazotization, NH2 become N2Cl. Br. What is HBF4? You know, HBF4 contain 2 ion, H plus and BF4 minus. What happened? H plus go with the Cl, you get the salt first. What is the salt? N2 plus BF4 minus. This will come here and Br. Finally, when you directly heat, when the salt directly heat, that becomes fluorobenzene. Fluorine come to this one, Br. Right? So what is the product? What is the product? 2,4,6 tribromofluorobenzene, that is option A. What is the reaction here? Aniline on bromine water, you will get 2,4,6 tribromoaniline. Diazotization, it becomes salt. Salt on HBF4, the Cl and H go to the N2, BF4 comes, on directly heat become fluorobenzene. That is our Bals-Schiemann reaction. Next, identify X, Y, Z. What is this? Aniline on what? You get these 3 bromine. We know that it is bromine with aqueous. This bromine water. Where is that? Where is that? That is only one option, D. Then on what you get N2Cl, NH2, how become N2Cl? NaNO2 and HCl diazotization. Yes. And how you can completely cut this N2Cl? We can use H3PO2 along with H2O or ethanol also fine. Okay, D, correct. Next one. What is the correct IUPAC name of the following amine? CH2 double bond, CH single bond, CH2 single bond, NH single bond, CH3. Right? Start all of you. Where is the biggest chain on nitrogen? This side. So prop is the parent chain. So this is the branch. Amine is there, double bond is there. Amine having more priority. So 1, 2, 3. We can start N-methyl. N-methyl. Total 3 carbon, therefore proper. Second position alkene, so 2 ene. First position amine, so 1 amine. N-methyl, proper 2 ene, 1 amine. Where is that? N-methyl, proper 2 ene, 1 amine, right? Option D. Question number 90. Among the following, which is the strongest base in aqueous medium? They are all this here nitrogen connected to benzene ring, aromatic. Aromatic is very least basic. Cut it. This is aliphatic. You know, in aqueous medium, if methyl group comes, the order secondary, primary, tertiary. Where is secondary? This is secondary. Option C, more basic. So first you classify them as aliphatic, ammonia and aromatic. Aliphatic is the most basic, no doubt. In aqueous medium, in 2 special cases we studied. Here methyl present, so secondary, primary, tertiary is the order. So secondary C. Question strongest base. Okay. Question 91. What is the correct increasing order of the basic strength? Start. All are aniline, all are aromatic. You know, nitro group is a withdrawing group, alkyl groups are donating group. Who can increase the basicity? Donating group. So no doubt, third one is most basic. So third one most basic, yes, this one. Then this, and last one is with withdrawing group. So more donating group, more basic, more withdrawing group, least basic. Finish. Next one. The gas evolved when methylamine. What is methylamine? CH3NH2 with nitrous acid, HNO2. Many times we discussed. When primary aliphatic amine reacted with the HNO2, that becomes salt. What is a salt? N2 plus Cl minus. We know alkyl diazonium salt is highly unstable, that is because no resonance. So immediately react with the water. You know, water contain H plus and OH. So CH3 combined with OH, you get CH3OH, it become alcohol. The nitrogen gas come out plus along with this HNCl, HCl. So what is the gas here? Nitrogen gas. So the gas evolved when methylamine react with the nitrous acid is which one? Nitrogen gas, dear all. Next one. In the nitration of benzene, using a mixture of concentrated H2SO4 and HNO3, the species which initiate the reaction is, you know, benzene when we treated with the concentrated HNO3 and concentrated H2SO4, they are asking you which group come to the benzene. You know, nitro group. Where you studied this reaction as general electrophilic substitution. Electrophiles are coming with a positive charge, dear all. If it is chlorination, Cl plus is the upcoming group. Nitration mean NO2 plus. Alkylation mean the alkyl group. Acylation mean the acyl group. All are electrophile. They are coming with a positive charge. So where is NO? During nitration, which is the upcoming group? NO2 plus. Okay, NO2 plus. Question number 94. Which of the following compound will not undergo azo coupling reaction with the benzene diazonium chloride? We studied two reactions in coupling reaction. Hope you remember. Benzene diazonium chloride we treated with the phenol and the aniline. We get orange dye and yellow dye. So the question is, remember all of it, this is the point. If it want to undergo coupling reaction, we have already benzene diazonium chloride. Benzene diazonium chloride is there. The another group should be contain a electron donating group. Okay, benzene diazonium chloride when react with a aromatic system with the EDG, electron donating group, undergo coupling reaction faster. So they are asking which of the following compound will not undergo coupling reaction. That means there is a withdrawing group. Which is a withdrawing group? Nitro. Nitro group is a withdrawing. You know, aniline mean NH2. Phenol mean OH. Anisole mean OCH3 on benzene. Nitro is NO2. We know nitro group is the withdrawing group. Here these all are what? Donating group. If there is a donating group is coupling with the diazonium salt, yes, it undergo reaction faster. Which do not undergo coupling reaction mean there is a withdrawing group, just keep in mind. So that is nitrobenzene. Which of the following should be most volatile? Dear all, most volatile mean they are easy to vaporize. Most volatile means they having least boiling point. Lesser the boiling point, easy to vaporize. So you know the boiling point order, we know primary greater than secondary greater than tertiary is the order of boiling point. So which one is the least boiling point? Tertiary. Where is tertiary? Where is tertiary? This is primary, this is secondary, this is hydrocarbon, and this is what? Which one? Second one. This is tertiary. Tertiary cannot form any hydrogen bond, so therefore it is least which one? Basic one we can least boiling point. So third one is tertiary. So most volatile means what? They are having least boiling point. The least boiling point is given by the amine, tertiary amine. Okay. So second one. Next one, when aniline react with, okay, write the reaction fast. When aniline react with NaNO2 and HCl at 0 to 5 degree, what is the product form? What is this? Diazonium salt, right? What happened? Benzene becomes, this becomes NH2 become N2Cl. What is this compound called? Benzene diazonium chloride. Benzene diazonium chloride. Don't convert into alcohol, okay, because it's already stable compound, so it is not normal water, it won't react. So when aniline react with NaNO2 HCl, it give diazonium salt. Next, a unpleasant smelling carbylamine. We know carbylamine test having, that's isocyanide having foul smell. Unpleasant smelling carbylamine are formed by heating alkali and chloroform with, we know, a primary amine. The carbylamine test is given by what? Primary aliphatic or primary aromatic amine. When primary aliphatic or primary aromatic amine, when treated with alkali like NaOH and chloroform, give you what? Foul smell isocyanide. So what is that? Any amine not possible. Any aliphatic amine Not possible. Any aromatic amine, not possible. It should be any primary amine. Means any primary means it can be primary aromatic or primary aliphatic. Okay. Next. For the preparation of para-nitroiodobenzene. Para-nitroiodobenzene. Okay. Para-nitroiodobenzene from para-nitroaniline. What is the best method? What is the overall conversion here? Nitro is already there. We want to convert NH2 to iodine. What is that? First we have to treat it with what? NaNO2 and HCl. We get diazonium salt. NH2 become N2Cl. Later on treated with which one? Ki, warm Ki. So iodine come to benzene. So which is the best method, my dear? Tell me, Ki where it is NaNO2 HCl followed by K, right? Option A, right? Yes, Cu, Cn, I2 and can use it. Iodine if you want to get, always Ki we have to use it. Second last question, 99. C3H9N. We discussed this one question another way. C3H9N. Let me write the possible structure. Okay, 3 carbon with an amine. 3 carbon I can draw like an amine like this one. Propanamine. Now I can place the amine on the second carbon. This is called propan-2 amine. I'm saying the possible structure. Okay. This is primary. Now this is secondary possible. N-methyl ethanamine. One more is possible. CH3N, CH3, CH3. A tert methyl or tert methyl trimethylamine. Question. This amine. These are the possible structure for this amine. Question. This amine represent. Yes, primary amine possible. These are primary. Secondary amine possible. This is secondary. Tertiary amine possible. All of this. Yes, we can go with option D. So, with the C3H9N formula, all the 3 amines are possible. These are the 4 amines. Here all our last question, 100th question. What is the number of isomeric primary amines obtained from? How many primary amines are possible with the formula? C4H11N, overall 4 carbon. How many primary amines are possible? What is primary amine? They should contain NH2 group. Check it out. First one is CH3, CH2, 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 NH2. This is one possible. This is butanamine, right? Let me place NH2 on the second carbon. So I can write CH3, CH2, CH, NH2, CH3. Butan-2 amine. This is primary amine. Now let me change the carbon chain. Let me write CH3, CH, CH3, CH2, NH2. This is one another. Now let me make the another carbon chain here. CH3, C, CH3, CH3, NH2. Possible, right? So I think around 4 structures I got it. Can you please cross check it? Any other structure is possible or not? 4 carbon chain. This is the maximum possible. 1 on first position, second position. Finish. Now 1 carbon I made it as a branch. Now 2 carbon made it like a branch system like that. So I think this is the maximum structure possible. So with the primary amine, we have total 4 structures are possible. So here, my dear, around 100 MCQs we discussed, 100 MCQ we discussed about the amine chapter. I think all the chapter, almost all the chapter, all the concepts, including basicity, reactions, distinguishing test, everything we discussed in this 100 MCQ. Hope you are confident in this one. Those who are not confident in the chapter, that's only because of this theory. Theory you make it, theory you catch it with you. Theory you have to hold in your mind properly and just apply, okay, where I studied. Whenever I'm discussing this question, when I'm showing the question, pause the video and just find the answer. Then you just cross check with the explanation. Hope you clear everything and do your best, all of you. Wish you all the very best for your upcoming examination. All the best.